Class 10 Polynomials, Exercise 2.1, first question. The graphs of y is equal to p of x are given in the figure below. For some polynomials p of x, find the number of zeros of p of x in each case. So observe this figure. From the graph, it is clear that it does not meet x-axis at any point. So here it has nil or 0, or you can say it has no zeros because it cannot touch x-axis at any point. Second one, observe this graph, two-dimensional graph. From the graph you can say that it is meeting x-axis at only one point. It is clear that it meets x-axis at only one point. You can see here this is x-axis and it meets at only one point. So therefore number of zeros is 1 here. Now third one, from the graph it is clear that it meets x-axis at dash points. You can see this graph x-axis 1, 2, 3 points. So it meets x-axis at 3 points. Therefore number of zeros is 3 here. See the fourth graph. From the graph it is clear that it meets x-axis at dash points. See this graph, x-axis and 1, 2 dot points. So therefore number of zeros is 2 here because it meets x-axis at 2 points. Now observe the fifth figure. Say that from the graph it is clear that it meets x-axis at dash points. See this graph, x-axis 1, 2, 3, 4. So it meets at 4 points. So therefore number of zeros is 4 here. Now sixth figure, from the graph it is clear that it meets x-axis at dash points. So see the graph, x-axis here 1, 2, 3. So it meets at 3 points. Therefore number of zeros is 3 here. Now exercise 2.2, first question. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. First one, x square minus 2x minus 8. Minus 8 can be divided as minus 4 into 2. Now simplify this term. X square minus 4x plus 2x minus 8 is equal to 0. Here take x as common. Remaining term x minus 4 plus 2. X minus 4 is equal to 0. Now x minus 4 into x plus 2 is equal to 0. Or you can write x minus 4 is equal to 0 or x plus 2 is equal to 0. Here x is equal to 4 or x is equal to minus 2. Therefore zeros of x square minus 2x minus 8 are minus 2 and 4. Now find out sum of zeros, which is equal to minus 2 plus 4, that is 2. Or you can write 2 as minus of minus 2 by 1, that is minus coefficient of x by coefficient of x square. Product of zeros zeros are minus 2 into 4, it is minus 8. Minus 8 by 1, that is minus 8 is a constant term and 1 is a coefficient of x square. So this holds good. Hence, relationship between the zeros and the coefficient are verified. Now second one, 4s square minus 4s plus 1. Here 1 into 4 is 4. So factors are 2 into 2, minus 2 into minus 2. Then this equation becomes 4s square minus 2s plus 1. Here take 2s as common. Remaining terms are 2s minus 1 in bracket 2s minus 1. Now 2s minus 1 into 2s minus 1 is equal to 0, or you can write 2s minus 1 is equal to 0 or 2s minus 1 is equal to 0. Here s is equal to 1 by 2. Again here also s is equal to 1 by 2. Therefore, zeros are 1 by 2 and 1 by 2 itself. Sum of zeros are 1 by 2 plus 1 by 2, that is 1, or you can write it as minus of minus 4 by 4, that is in the form of minus coefficient of x by coefficient of x square. So it is also verified. Now product of zeros, you have to multiply 1 by 2 into 1 by 2, you get 1 by 4. 1 is a constant term here, 4 is a coefficient of x square. This relation is also verified now. You can write hence the relationship between these polynomial and the coefficient is verified. Third one, 6x square minus 3 minus 7x. This can also be written as 6x square minus 7x minus 3 is equal to 0. 6 into 3 is 18, minus sign is there, minus 18. Minus 18 factors are 9 into 2. Now you simplify this term, find the values of x here. So likewise you have to find 3x plus 1, 2x minus 3 is equal to 0. Here 3x plus 1 is equal to 0 or 2x minus 3 is equal to 0. Here x becomes minus 1 by 3, here x becomes 3 by 2. Therefore, now zeros are 1 minus 1 by 3 and 3 by 2. Now find out sum of zeros and product of zeros. Sum of zeros is equal to minus 1 by 3 plus 3 by 2. Take 6 as LCM now. It becomes minus 2 plus 9, that is 7 by 6, which is equal to minus of minus 7 by 6, that is minus of coefficient of x divided by coefficient of x square. This relation is verified now. Product of zeros is equal to minus 1 by 3 into 3 by 2. 3 get cancelled, minus 1 by 2, which is equal to minus 3 by 6. Again minus 3 is a constant term in the equation and 6 is the coefficient of x square. Now fourth one, 4u square plus 8u. Here take 4u, or you can write 4u square plus 8u plus 0 is equal to 0. Take 4u common into u plus 2 is equal to 0. Here 4u is equal to 0 or u plus 2 is equal to 0. Hence u is equal to 0 or u is equal to minus 2. Therefore zeros are 0 and minus 2. Find out sum of zeros. Sum of zeros are 0 plus of minus 2, that is minus 2. Or you can write it as minus 8 by 4, that is nothing but minus 2 itself. It is in the form of minus coefficient of u by coefficient of u square. Now product of zeros. 0 into minus 2, that is 0 itself. 0 by 4 you can write. 0 is a constant term and 4 is a coefficient of u square. So this relation is also verified now. Now question number 5, t square minus 15. This is equal to t square minus 15 is equal to 0. It becomes t square is equal to 15, or you can write t is equal to square root plus or minus square root of 15. Here zeros are plus root 15 and minus root 15. Now find out sum of zeros, which is equal to plus root 15 plus of minus root 15, which is 0. 0 can be written as minus 0 by 1, which is equal to minus of coefficient of t by coefficient of t square. Now product of zeros. Product of zeros, multiply square root of 15 into minus square root of 15, you will get minus 15, or you can write it as minus 15 by 1, that is constant term by coefficient of t square. Now next question, 6th, 3x square minus x minus 4. Here 3 into minus 4 is minus 12, hence the factors are minus 4 into 3. Now simplify this term, 3x square minus 4x plus 3x minus 4 is equal to 0. It becomes now 3x minus 4 is equal to 0 or x plus 1 is equal to 0. Hence the x term will become 4 by 3 or minus 1. Therefore, zeros are minus 1 and 4 by 3 here. Find out sum of zeros, minus 1 plus 4 by 3. Here LCM will be 3. Minus 1, that is minus 3 plus 4 is 1 by 3, or you can write minus of minus 1 by 3, that is minus of coefficient of x by coefficient of x square. Now find out the product of zeros. For the product of zeros, you have to multiply these two terms, minus 1 into 4 by 3, minus 4 by 3, or you can write it as constant term divided by coefficient of x square. So it is also correct here. Now second question, find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. First question, 1 by 4 comma minus 1. Here what they have given, that is a zeros terms. Let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Here 1 by 4 is sum of zeros and minus 1 is product of zeros. Alpha plus beta is equal to 1 by 4, that is minus b by a. Alpha into beta is equal to minus 1, that is you can write it as minus 4 by 4, which is equal to c by a. If a is equal to 4, then b is equal to minus 1 and c is equal to minus 4. Therefore, quadratic polynomial is 4x square minus x minus 4. Second one, root 2 comma 1 by root 2 is alpha plus beta, 1 by 3 is alpha into beta. Now right here, let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Alpha plus beta is equal to root 2, or you can write it as 3 root 2 by 3, which is equal to minus b by a. Alpha into beta is equal to 1 by 3 given, which is equal to c by a. Here if a is equal to 3, then b becomes minus 3 root 2 and c is 1. Then polynomial will be 3x square minus 3 root 2x plus 1. Now third question, 0 comma root 5. Now write down, let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. 0 is alpha plus beta and root 5 is alpha into beta. Alpha plus beta, that is 0 equal to 0 by 1, h is equal to minus b by a, and alpha into beta is equal to root 5, which is equal to root 5 by 1, which is equal to c by a. If a is equal to 1, then b is equal to 0 and c is equal to root 5. Then polynomial is x square plus root 5. Fourth one, 1 comma 1. Let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Alpha plus beta is equal to 1, which is equal to 1 by 1, or you can write minus b by a. Alpha into beta is equal to 1, or you can write 1 by 1, which is equal to c by a. If a is equal to 1, then b is equal to minus 1 and c is equal to 1. Then its quadratic polynomial is x square minus x plus 1. Fifth one, minus 1 by 4 comma 1 by 4. Here let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Alpha plus beta is equal to minus 1 by 4, that is minus b by a. Alpha into beta is equal to given as 1 by 4, which is equal to c by a. If a is equal to 4, then b is equal to 1 and c is equal to 1. Then quadratic polynomial is 4x square plus x plus 1. Sixth one, 4 comma 1. Let the polynomial be ax square plus bx plus c and its zeros be alpha and beta. Here alpha plus beta is given as 4, alpha into beta is given as 1. Alpha plus beta is minus b by a, alpha into beta is c by a. If a is equal to 1, then b becomes minus 4 and c becomes 1. Hence quadratic polynomial is x square minus 4x plus 1. Now exercise 2.3, first question. Divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. First question, p of x is equal to x cube minus 3x square plus 5x minus 3, and g of x is equal to x square minus 2. You have to divide these two terms. X cube minus 3x square plus 5x minus 3, divide it with x square minus 2. X square into x is x square minus, no, multiply minus 2 into x, it becomes minus 2x. So solve this division. Like this. Now quotient is here x minus 3 and remainder is 7x minus 9. Second one, p of x is equal to x to the power 4 minus 3x square plus 4x plus 5, or you can write it as x to the power 4 plus 0x cube minus 3x square plus 4x plus 5, and g of x is given as x square plus 1 minus x. You can write it as x square minus x plus 1. Now divide these two terms. So see here, like this you have to divide. X square into x square, it becomes x raised to 4, and sign changes here and it cancels. In the first case, x to the power 4 is cancelled. In second term, x to the power 3 is cancelled. In next term, minus 3x square plus 3x is cancelled and remainder is 8. Here quotient is x square plus x minus 3 and remainder is 8. Now third one. Write down p of x is equal to x to the power 4 minus 5x plus 6 and g of x is equal to minus x square plus 2. Now divide x to the power 4 minus 5x plus 6 with minus x square plus 2. Multiply with minus x square, it becomes x raised to 4 minus 2x square. Sign changes, this cancel, 2x square remaining and other terms are minus 5x plus 6. Now multiply it with minus 2, you get minus 2x square minus 4, this get cancelled, minus 5x plus 10 is remaining. Here quotient is minus x square minus 2 and remainder is minus 5x plus 10. Second question, check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. So this t square minus 3 can be written as t square plus 0t minus 3 and 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12. So divide it, t square into 2t square, whenever you multiply you will get a 2t raised to 4. So first term you cancel it. Likewise, try to cancel the next term by multiplying it with 3t. So now second term is also get cancelled. Remaining terms are 4t square minus 0t minus 12. Now plus 4t square minus, now all the terms get cancelled here. Here remainder becomes 0. Now write down 0 as a remainder. Since the remainder is equal to 0 here, hence t square minus 3 is a factor of the term or factor of the polynomial 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12. Now second one, divide these two terms, 3x raised to 4 plus 5x cube minus 7x square plus 2x plus 2, divide it with x square plus 3x plus 1. So now I will multiply with 3x square, it becomes 3x raised to 4 plus 9x cube plus 9x square, cancel first term, remaining terms are minus 4x cube minus 10x square and other terms are 2x plus 2. Now multiply it with minus 4x, you will get minus 4x cube minus 12x square minus 4x. This get cancelled here. Remaining terms are 2x square plus 6x plus 2. Now multiply it with 2, will get 2x square plus 6x plus 2. Sign get changes and remainder becomes 0 here. Since the remainder is equal to 0, hence x square plus 3x plus 1 is a factor of the polynomial 3x raised to 4 plus 5x raised to 3 minus 7x square plus 2x plus 2. Third one, divide these two terms, x raised to 5 minus 4x cube plus x square plus 3x plus 1 with a x cube minus 3x plus 1. Multiply it with x square, you will get x raised to 5 minus 3x cube plus x square. Sign get changes and get cancelled. Remaining terms are minus x cube and other terms are 3x plus 1. Now multiply it with minus 1, you will get minus x cube plus 3x minus 1. Here sign get changes and all the terms get cancelled, but here 1 plus 1 becomes 2. Here remainder is not equal to 0. Hence x cube minus 3x plus 1 is not a factor of the polynomial x raised to 5 minus 4x cube plus x square plus 3x plus 1. If remainder is 0, then only it is a factor, otherwise it is not a factor. Third question, obtain all other zeros of 3x raised to 4 plus 6x raised to 3 minus 2x square minus 10x minus 5 if two of its zeros are square root of 5 by 3 and minus square root of 5 by 3. Write down p of x. Since the zeros are square root of 5 by 3 and minus square root of 5 by 3, therefore x minus square root of 5 by 3 into x plus square root of 5 by 3 is equal to a minus b into a plus b formula you apply here. It becomes x square minus 5 by 3 is a factor of the polynomial p of x here. X square minus 5 by 3 divide that is a dividend. Divide it with 3x square plus 6x cube minus 2x square minus 10x minus 5. Multiply it with 3x square. First term get cancelled and other remaining terms you write down here. And again multiply with 6x. It becomes 6x cube minus 10x. Sign get changes. These two terms get cancelled. Remaining terms 3x square minus 5. Multiply it with 3. We'll get 3x square minus 5. And remainder becomes 0 because all the terms get cancelled here. 3x raised to 4 plus 6x cube minus 2x square minus 10x is minus 5 is equal to, write down this quotient here, 3x square plus 6x plus 3 into x square minus 5 by 3. You can take 3 outside, it becomes 3 into x square minus 5 by 3 into x square plus 2x plus 1. We factorize this x square plus 2x plus 1 as x plus 1 whole square. Therefore, its zeros is given by x plus 1 is equal to 0 or x is equal to minus 1. As it has the term x plus 1 whole square, therefore there will be two zeros at x is equal to minus 1. Hence, the zeros of the given polynomial are square root of 5 by 3 minus square root of 5 by 3 minus 1 and minus 1. Question number 4. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find g of x. Here p of x is equal to x cube minus 3x square plus x plus 2. It is a dividend. You have to find a divisor, that is g of x is equal to question mark and quotient given as x minus 2, remainder as minus 2x plus 4. Now you know that dividend is equal to divisor into quotient plus remainder. Here dividend is x cube plus minus 3x square plus x plus 2. Divisor you don't know, write it as g of x into quotient is x minus 2 plus remainder is in bracket minus 2x plus 4. This can also be written as x cube minus 3x square plus x plus 2 plus 2x minus 4 is equal to g of x into x minus 2. And this becomes x cube minus 3x square. These x and x will be added plus 3x minus 2 is equal to g of x into x minus 2. Here g of x is the quotient when we divide x cube minus 3x square plus 3x minus 2 by x minus 2. So divide these two terms here, x cube minus 3x square plus 3x minus 2, divide it with x minus 2, multiply it with x square, it becomes x cube minus 2x square. Sign changes, these two get cancelled. Write down the remaining terms, x square plus 3x minus 2. Now multiply it with minus x, first term get cancelled, remaining terms are x minus 2. So plus 1. Now remainder becomes 0 here and quotient will be x square minus x plus 1. Therefore g of x becomes x square minus x plus 1. Fifth question. Give examples of polynomials p of x, g of x, q of x and r of x which satisfy the division algorithm. And first is degree of p of x is equal to degree of q of x. First, we know that according to the division algorithm, if p of x and g of x are two polynomials with g of x is not equal to 0, then we can find polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x. So first one will take degree of p of x is equal to degree of q of x. So let us take an example that let p of x is equal to 5x square minus 5x plus 10 and we can take g of x as 5. Now divide these two terms, 5 with 5x square minus 5x plus 10, 5x square. So multiply it with x square, remaining terms are minus 5x plus 10. Now multiply it with minus x, first term get cancelled, remainder is 10. Now again it will be divided, 5 2s are 10. Now remainder is 0 here. And quotient is q of x is x square minus x plus 2 and remainder is 0. Therefore, by division algorithm, 5x square minus 5x plus 10 is equal to 5 into x square minus x plus 2 plus 0. So here this term is p of x which is equal to g of x into q of x plus r of x. So it is in the form of first one. Therefore here degree of p of x you can observe and degree of q of x both are 2 itself. So thus the division algorithm is satisfied. Now second one, degree of q of x is equal to degree of r of x. For this question, let us consider that let p of x is equal to 7x cube minus 42x plus 53 and g of x as x cube minus 6x plus 7. Now divide these two terms. 7x cube minus 42x plus 53 divide with x cube minus 6x plus 7. Multiply it with 7, you will get 7x cube minus 42x plus 49. First two terms get cancelled and remainder is 4. Now here quotient is q of x is equal to 7 and the remainder is r of x is equal to 4. Therefore by division algorithm, here 7x cube minus 42x plus 53 is equal to 7 into x cube minus 6x plus 7 plus 4. So it is in the form of p of x is equal to q of x into g of x plus r of x. Here degree of q of x is equal to what? It is a see here degree is 0 and remainder degree is also 0. Here it is satisfied the division algorithm. Now third one, degree of r of x is equal to 0. For this question let us consider that p of x is equal to 4x cube plus x square plus 3x plus 6 and g of x is equal to x square plus 3x plus 1. Now divide these two terms, 4x cube plus x square plus 3x plus 6. Divide it with x square plus 3x plus 1. So here quotient is 4x minus 11 and remainder is 32x plus 17. Write down q of x is equal to 4x minus 11, r of x is equal to 32x plus 17. By division algorithm, 4x cube plus x square plus 3x plus 6 is equal to 4x minus 11 into x square plus 3x plus 1 plus 32x plus 17. It is in the form of p of x is equal to q of x into g of x plus r of x. Here degree of q of x is what? It is 1, which is equal to degree of r of x. R of x degree is also 1 and q of x degree is also 1. Hence it is satisfied. Now exercise 2.4. Verify that the numbers given alongside of the cubic polynomials below are their zeros. Also verify the relationship between the zeros and the coefficient in each case. First question, write down this as p of x is equal to 2x cube plus x square minus 5x plus 2 and zeros of this polynomial are 1 by 2, 1 and minus 2. Here p of 1 by 2, now in place of x put 1 by 2. For the polynomial p of x, you will be getting 1 by 4 plus 1 by 4 minus 5 by 2 plus 2. Now again you simplify these terms. It will be 0. And find out it for p of 1. So simplify like this, 2 plus 1 minus 5 plus 2. Again this is also 0. Find out for p of minus 2. This should also become 0. So it is simplified as minus 16 plus 4 plus 10 plus 2. It is also 0 now. Therefore 1 by 2, 1 and minus 2 are the zeros of the polynomial p of x, or you can write zeros of the given polynomial. Comparing the given polynomial to x cube plus x square minus 5x plus 2 with x cube plus bx square plus cx plus d. We get that a is equal to 2, b is equal to 1, c is equal to minus 5, d is equal to 2. We can take here alpha 1 by 2, beta 1, gamma as minus 2. Alpha plus beta plus gamma is equal to, now add all these terms, you will get 1 by 2 minus 1, that is minus 1 by 2, that is equal to minus b by a. Now alpha into beta plus beta into gamma plus alpha into gamma, that is 1 by 2 into 1 plus 1 into minus 2 plus 1 by 2 into minus 2. Whenever you simplify these two terms, you will get minus 5 by 2, which is equal to c by a. Now product of all the terms, alpha into beta into gamma, that is 1 by 2 into 1 into minus 2. That will be minus 1 by 1, or you can write minus 2 by 2, that is minus d by a. Therefore, relationship between zeros and the coefficient is verified. Second one, x cube minus 4x square plus 5x minus 2. Here write down this polynomial as p of x and zeros are 2, 1, 1. So find out p of 2 and p of 1. So that should be equal to 0. Here p of 2 becomes 0. Now find out it for p of 1. So p of 1 should also be 0. Now it is 0. Therefore 2, 1, 1 are the zeros of the given polynomial. Compare the given polynomial, that is x cube minus 4x square plus 5x minus 2 with ax cube plus bx square plus cx plus d. Then a is equal to 1, b is equal to minus 4, c is equal to 5, d is equal to minus 2. Now find out sum of zeros, product of zeros. Sum of zeros, that is alpha plus beta plus gamma, that is 2 plus 1 plus 1 is 4, that is equal to minus b by a. Then find out multiplication of zeros or product of zeros, that is alpha into beta into gamma, which is equal to 2 into 1 into 1 is equal to 2. That can also be written as minus of minus 2 by 1, that is minus d by a. Again find out c by a, that is alpha into beta plus beta into gamma plus alpha into gamma, that is 2 into 1 plus 1 into 1 plus 2 into 1, that is 5 by 1, which is equal to c by a. Hence relationship between zeros and coefficient is verified here. Now second one, find a cubic polynomial with the sum of products of its zeros taken 2 at a time and the product of its zeros as 2, minus 7, minus 14 respectively. So here let the polynomial be ax cube plus bx square plus cx plus d and zeros be alpha, beta and gamma. Here given as alpha plus beta plus gamma as 2 by 1, that is minus b by a, and alpha into beta plus beta into gamma plus alpha into gamma is given as minus 7 by 1, that is c by a, and alpha into beta into gamma is given as minus 14 by 1, that is minus d by a. Here if a is equal to 1, then b is equal to minus 2, c is equal to minus 7, d is equal to 14. Hence the polynomial becomes x cube minus 2x square minus 7x plus 14. Third one, if the zeros of the polynomial x cube minus 3x square plus x plus 1 are a minus b, a plus b, find a and b. Here write down p of x as x cube minus 3x square plus x plus 1. Zeros are a minus b, a plus b. Comparing the given polynomial with, so that is comparing the given polynomial with px cube plus qx square plus r of x plus 1, then we get p is equal to 1, q is equal to minus 3, r is equal to 1, t is equal to 1. Now find out sum of zeros, that is a minus b plus a plus a plus b. So these are the three terms you have to add, that becomes 3a, which is equal to minus q by p. Now 3a is equal to minus q by p is minus of minus 3 by 1. It becomes 3a is equal to 3, hence a is equal to 1 now. Likewise find for b also. The zeros are now 1 minus b, 1 and 1 plus b. Now multiplication of zeros or product of zeros, 1 into 1 minus b into 1 plus b, which is equal to 1 minus b square, that is equal to minus t by p. So here minus t is minus 1, p is 1. Therefore 1 minus b square is equal to minus 1. Then b square will become 1 plus 1. B is equal to plus or minus root 2. So we got a value and we got b value. Hence a is equal to 1 and b is equal to root 2 or minus root 2. Question number 4. If two zeros of the polynomial p of x are 2 plus or minus root 3, find other zeros. So given that 2 plus root 3 and 2 minus root 3 are zeros of the polynomial, therefore x minus 2 minus root 3 into x minus 2 plus root 3 is equal to x square plus 4 minus 4x minus 3, which is equal to x square minus 4x plus 1. So it is a factor of the polynomial. Now let us divide p of x with the factor. So p of x is x raised to 4 minus 6x cube minus 26x square plus 138x minus 35. Divide it with x square minus 4x plus 1. We will get a quotient as first x square minus 2x. So multiply 2x with all the terms here. So first term get cancelled, remaining terms write down minus 35x square plus 140x minus 35. Again multiply it with minus 35. It becomes minus 35x square plus 140x minus 35. So here all the term get cancelled, remainder is 0. Hence, or you can write it as x raised to 4 minus 6x square minus 26x square plus 138x minus 35 is equal to x square minus 4x plus 1 into quotient is x square minus 2x minus 35 plus remainder is 0, and x square minus 2x minus 35 can also be written as x minus 7 and x plus 5, that is x minus 7 is equal to 0 or x plus 5 is equal to 0. Here x becomes 7 or minus 5. Hence 7 and minus 5 are also zeros of the polynomial. Fifth question. If the polynomial x raised to 4 minus 6x cube plus 16x square minus 25x plus 10 is divided by another polynomial, the remainder comes out to be x plus a. Find k and a. So you know that by division algorithm, dividend is equal to divisor into quotient plus remainder. This becomes now dividend minus remainder is equal to divisor into quotient. So here dividend is x raised to 4 minus x cube 6x cube plus 16x square minus 25x plus 10, and remainder is x plus a, that becomes minus of x minus a, which is equal to divisor into quotient. So here will be perfectly divisible by x square minus 2x plus k. So divide x raised to 4 minus 6x cube plus 16x square minus 25x plus 10. So 25 becomes here 26x plus 10 minus a. Divide it with x square minus 2x plus k. So follow this method now. First multiply it with x square. Afterwards multiply it with minus 4x. Again multiply it with 8 minus k. and simplify all the terms. So change of sign, first term get cancelled and remaining terms you write down here. Minus 10 plus 2k into x plus 10 minus a minus 8k plus k square. It can be observed that minus 10 plus 2k into x plus 10 minus a minus 8k plus k square is equal to 0. Minus 10 plus 2k into x is equal to 0, or 10 minus a minus 8k plus k square is equal to 0. Here minus 10 plus 2k is equal to 0. Find k value. It becomes 5. If k is equal to 5, then find a value. 10 minus a minus 8 into 5 plus 5 square is equal to 0. Now simplify these terms. You will get a minus 5. A is equal to minus 5. Hence k is equal to 5 and a is equal to minus 5. Thank you. Like and subscribe my channel.